In this example of linear equations in the real world, perhaps you are given the task to drain the pool at a certain time. The time that it should be completely drained is at 8 p.m. If you were to start the draining at 12 p.m., will it be empty by 8 p.m.? To solve this, we are going to graph the water depth versus time. You will be able to figure out how long it will take for the pool to completely drain. We plot the amount of times the drain was first opened at noon on the x-axis and water depth on the y-axis. So here's the y-axis, and this will be measuring water depth, and on the x-axis is elapsed time. Now the times were given to us, and so we know that at 1:30 the water level was at 10 feet, so we're going to graph 1 to 10. And then at 3 p.m., after 3 hours of draining, the level was at 8 feet. So we would put here. And finally, at 6 p.m., the water level was at 4 feet. So this is a linear graph going straight down. To prove that this graph is in fact linear, we are going to calculate the slopes of the line segments connecting the first and second point and the second and third point. If all 3 points are the same, then they must all line up on the same line. We can calculate the slope of a line which passes through 2 points. We will be focusing on the second and third point. So we can calculate the slope of a line which passes through 2 points as a difference in the points. Y-coordinates. To prove this graph is in fact linear, we are going to calculate the slopes of the line segments connecting the first and second point and the second and third point. If all 3 points are on the same line, or if all 3 points are the same, then they must all line up on the same line. We can calculate the slope of a line which passes through 2 points. So you're going to take the difference in the y-coordinate points. So we're focusing on second and third. So these are 4 and 8. So this would be delta y equals 4 minus 8. Then you will divide by the difference in their x-coordinates. So their x-coordinates are 3 and 6. So this is delta x equals 6 minus 3. Dividing delta y by delta x, so then we divide dividing delta y by delta x, we get negative 4/3 for a slope. So the overall slope being negative 4/3. So right here, this slope would be negative 4/3. Now we are going to calculate the slopes of points 1 and 2. Then again take the difference of the y-coordinates, which is 10 and 8 again. So it's delta y equals 8 minus 10. And then the difference of the x-coordinates, which is 1 and 3. So delta x equals 3 minus 1.5. And then we're going to divide them, delta y by delta x. And then 3 minus 1.5. And then when we solve this, we get negative 2 over 3/2. We can then simplify this by dividing negative 2 by 3/2. So negative 2 divided by 3/2. So it would be 2 over 3. And this then equals negative 4/3. The slope of this line is also 4/3, making the graph officially linear. Since we know the slope at least one point, we can write the equation of this line using the point-slope form. The point-slope form is y minus y1 equals m parentheses x minus x1. If we want to figure out what time the pool will be empty, we can set the water level y to 0 and solve the equation for x to see what elapsed time is at that point. So we are going to start by setting y as 0. So y will be 0 minus 4 equals negative 4/3 since the slope is 4/3, and then parentheses x minus 6. Since we are taking the very last point on our graph, 6/4 to solve this problem. So then 0 minus 4 then goes to negative 4. And since we are trying to find the value of x, we want to rearrange the equation so x is alone on one side. So we have negative 4 equals negative 4/3 x minus 6. So to do this, we're going to multiply negative 4/3 by the reciprocal, which is negative 3/4 on both sides. This cancels out and becomes 1. So then we have negative 3/4 times 4 equals 1 and 6. X equals 6. So then we're going to multiply 1 into x and 6, which is then just x minus 6. And then negative 3/4 times 4 comes out to be 3. Now we're just going to add 6 on both sides. And then x equals 9. Since x is the elapsed time and y is the water level, this result tells us that the water level y is 0 and the elapsed time will be 9 hours since the drain was opened at noon. This pool will not be empty until 9 p.m. So the answer to the question is, well, the question again was, if you were to start the draining at 12, will it be empty by 8? And the answer is no. If you were to start the draining at noon, then the pool won't be empty until 9 p.m.